7 years after Elon Musk revealed it to the world, SpaceX's Falcon Heavy rocket finally made its maiden test flight this past Tuesday. And against all odds, it worked almost perfectly, which is definitely not what I was expecting to say. The original intent of this test launch was just to get a payload into orbit around the sun and to prove the rocket works. In this case, the payload was one of Elon Musk's Tesla Roadsters, instead of something a little less flashy like a block of concrete with the same mass. Now, that Roadster is orbiting the sun as the first private payload to go farther than Earth's orbit, along with a dummy named Starman. That's one way to make the history books. SpaceX launched the Falcon Heavy from Pad 39A at Kennedy Space Center in Florida, which is the same pad that Apollo 11 used to get to the moon almost 50 years ago. Besides getting Elon's Tesla into orbit, they even managed to recover 2 parts of the rocket's first stage, or the part that gets the rocket off the ground, which touched down in a picture-perfect landing. Unfortunately, the third part didn't land quite so smoothly. But at least SpaceX can reuse 2 of the boosters for future missions, which saves a lot of time and money. Now that we know it works, the Falcon Heavy is officially the most powerful rocket humanity has at its disposal. Although it isn't the most powerful ever, that honor still belongs to the Saturn V, which sent us to the moon. But SpaceX hopes to use the Falcon Heavy to go beyond our natural satellite, like to Mars. It could also be used for missions to low Earth orbit, where it could launch up to 63.8 metric tons. That's equivalent to a fully loaded 737 aircraft, or just a whole lot of satellites. That power comes from the 27 engines in the rocket's first stage alone. It has so many engines because really the Falcon Heavy is like 3 of SpaceX's smaller rockets called Falcon 9s all lined up. And each Falcon 9, as the name suggests, has 9 first stage engines. Still, making sure that that many engines work together perfectly is a huge challenge. If they don't, things explode. Which somehow did not happen on Tuesday. Now that SpaceX knows their rocket works, the next step is to launch their first commercial payload, a satellite for a Saudi Arabian company that will likely launch later this year. Since that mission will be carrying something arguably more important than a Tesla, the stakes will be even higher. So here's hoping it goes just as well and that next time they can land everything successfully. While SpaceX was getting the Falcon Heavy ready for launch, another group of astronomers was publishing some even more out-of-this-world news. Last week, in the astrophysical journal Letters, they published the first evidence of planets outside the Milky Way, in a galaxy almost 4 billion light-years away. That doesn't seem possible. Well, to find them, they had to use one of the many quirks of general relativity. Astronomers from the University of Oklahoma analyzed the data of a quasar about 6 billion light-years away, named RxJ 1131-1231, which is so memorable. Quasars are extremely bright objects powered by the supermassive black holes at the centers of galaxies. And this one helped us track down those new planets in another galaxy closer to home. See, from Earth's vantage point, 1131's quasar actually sits behind another galaxy that's much closer to us, about 3.8 billion light-years away. But we're able to see it thanks to a consequence of general relativity known as gravitational lensing. This is where objects with a lot of mass, like galaxies, bend and distort and magnify the light from objects behind them. In this case, that means the intermediate galaxy bent the quasar's light like a lens. These lenses help astronomers see things that would otherwise be too dim, but the technique isn't helpful for studying things as small and as dim as planets. To find those objects, astronomers use another, less powerful version of gravitational lensing called microlensing. For this method, astronomers have to observe the lensed object, in this case the quasar, a bunch of different times, tracking how its brightness changes as the lens's position changes. If they see any spikes in that brightness, it means the object's light was distorted by planets hiding in the intermediate galaxy. Microlensing has been used to find exoplanets in the Milky Way, but this is the first time that it's been used to infer the presence of planets anywhere outside our galaxy. Now, to be clear, we don't have images of these planets. They're so far away that I'm going to go out on a limb and say we never will. We only believe they're there because the quasar's light signature indicates there has to be a lot of extra microlenses and therefore a lot of planets within the intermediate galaxy. And I mean a lot of planets. According to a computer program, you would need about 2,000 planets ranging in mass from Earth's moon to Jupiter for every main sequence star, one that's kind of like the sun, which is so many, but it's consistent with theoretical estimates, and there could be many more. For one, the data can only reveal potential rogue planets, because ones orbiting a star wouldn't cause enough of a microlensing effect on their own. Also, the team was only looking at a small part of the galaxy, so there's plenty of hope for discoveries. Overall, this isn't surprising news because astronomers totally expect planets to exist in galaxies other than our own. But the fact that we can finally say they are almost certainly there is a huge milestone, and this opens up the door for astronomers to learn more about these especially alien worlds. Thanks for watching this episode of SciShow Space. If you would like to keep learning about the universe with us, you can go to youtube.com/SciShowSpace and subscribe.